Consider the N2 molecule. We are asked to write the electron configuration for the first excited state. Consider the N2 molecule. We are asked to write the electron configuration for the first excited state of N2. Well, first, I'm just going to write the regular. There's our 1s orbital. So for our molecular orbitals, this happens. And in our 2s, that's full for each. So we have both of these full. And then in our p orbitals, each of the nitrogens has 3 electrons. I'm going to put them in like this just for fun. So we have 1, 2, 3, 4, 5, 6. So here is what our molecular orbital diagram would look for ground state N2. And what we're asked to do, and I'm just going to fill in, these two are the same. And for these 3 and these 3, we're told that, whoops, that goes down. One of these is promoted, and it's going to go right there into the next energy level. So this is, I'm thinking this is what they mean by the next energy level. And in order to write the electron configuration for this, I'm going to start right here. We're going to start with a sigma 1s with 2 electrons, a sigma antibonding for 1s with 2 electrons. That is this one, then this one. Next, we're going to have our sigma with our 2s and our sigma antibonding for our 2s. Those are those two. Now we're right here. So we're going to have our pi for our 2p, and you can see there are 4 electrons there. Then next we have our sigma for our 2p. And I'm going to switch to a highlight right here. Right here and right here is where the differences would be. We would have a pi for 2p with 2 electrons, and here I have a pi, or excuse me, a sigma with a 2p with 1 electron, and a pi antibonding for my 2p. I can't get my p in there with 1 electron. So I'm going to write that right here. This has 1. And then we have our pi antibonding for my 2p with 1 electron. We should have 14. We have 1, 2, plus 4 is 6, 8, 10, 12, 14. When we look at this molecule right here, we see that we have unpaired electrons. So this one is paramagnetic. Oh, let me write that somewhere else. I'm just going to write it up here. Paramagnetic. And I'm seeing what else I have to do here. Then it says, is the bond length, or is the bond strength stronger for the ground state or for the excited state? And I'm going to go back and forth here. For the ground state, let's figure out our bond order. It'll be 1/2 times my paired electrons, or excuse me, my bonding electrons minus my antibonding electrons. I'm going to switch to a pink highlighter, and I have 2, 4, 6, 8, 10. We have 10 bonding electrons. And from that, we're going to subtract our antibonding electrons, which we'll highlight in blue. We have 2, 4, 6. Oh, excuse me, 2, 4. Minus 4 equals 6 over 2 equals 3. So we have a bond order of 3 for our ground state. Now let's do the excited state. Again, we'll have 1/2 times, go back to our previous page. And over on our second diagram, let's do pink again. We have 2, 4, 6, 8, 9. We have 9 bonding electrons. So we're going to have 9 minus, let's go back and do our antibonding, 2, 4, 5. Equals 4 over 2 equals 2. So the bond strength is greater for the ground state because the bond order is greater. We're done.